You know, for an AI to be really, truly useful, it can't just be a thinker. It has to be a doer. It has to interact with the world. Today, we're going to pull back the curtain on a new standard that's making that happen. It's kind of like a secret language for AI, and it's called the Model Context Protocol. So, we all know AI models are incredibly smart, right? I mean, they can write code, they can ace exams, they can even write poetry that's not half bad. But what good is all that brainpower if it's trapped? The real question is, can it actually do anything?
And that, right there, is the fundamental problem. Without a way to connect to the outside world, even the most advanced AI is basically just a brain in a jar. It's stuck. All it can do is spit out patterns based on the data it was trained on. It can't check the current weather, it can't book a flight, it can't, affect anything.
So, how do we get that brain out of the jar? Well, we give it tools. Think of these tools as the AI's eyes and hands. A tool is just a simple function that lets the AI do one of two things. Either know something new, like fetching data from a website, or do something new, like actually making a purchase or sending an email. Okay, great. So tools are the answer. Problem solved, right? Well, not so fast. Because this creates a whole new headache. How in the world do you connect every different AI model out there to the thousands and thousands of tools they could potentially use? You guessed it, you run headfirst into an integration nightmare.
This slide just lays it out so perfectly. It's what developers call the N by M problem. For every model, that's N, you have to build a custom-coded connector for every single tool. That's M. So you add a new model, you got to build all those connectors again. You add a new tool, same thing. It doesn't just add up, it explodes. And let's be honest, calling it an exponential mess is probably an understatement. This one-off, custom approach is just pure chaos. It's wildly inefficient, and for a real company trying to build something, it's completely, totally unscalable.
So, to clean up this disaster, the industry needed something completely different. It needed a common language, a universal translator for AIs and their tools.
And that universal translator is the Model Context Protocol, or MCP. It's an open standard that basically says, hey, instead of a million custom connections, let's just have one. It creates a single unified interface. So now any model that speaks MCP can talk to any tool that speaks MCP. It's a genuine plug-and-play solution.
So how does this actually work under the hood? It's really kind of simple. There are three parts. You've got the host, that's the app you're using. Then you have the client, which is like a little messenger living inside the app. It takes your request and sends it to the server. And the server is the powerhouse that actually has all the tools ready to go. Now, the protocol has a few different features, but this chart tells the real story. I mean, just look at that first bar. The tools capability has a 99% adoption rate. This isn't just one cool feature, it's the entire reason MCP exists. It is, without a doubt, the core value driver. It's all about letting the AI do things. Okay, so MCP is the hero, right? It solves this massive integration headache. We're all good. But, and this is a big but, there's a twist. By giving AI all this power and flexibility, we've also opened a Pandora's box of brand new and pretty scary security risks. I mean, it's the classic story, isn't it? With great power comes great risk. By creating a universal plug for AI to connect to the world, we've also accidentally created a universal attack surface. And these aren't your typical cybersecurity problems. These are totally new vulnerabilities, born from the unique way these AI agents think and act. All right, let's dive into the first major threat. It's a sneaky concept called tool shadowing. This is where a bad, malicious tool can basically put on a disguise and trick the AI into picking it over a safe, legitimate one.
Here's how the con works. Let's say you have a legitimate tool with a very specific, safe description, like store a code snippet in the corporate vault. Now, an attacker creates a shadow tool with a much broader, more tempting description, like save any important data to a secure repository. The AI, just trying to be helpful, sees the broader tool and thinks, oh, that one looks more useful. And just like that, it picks the malicious tool and sends your sensitive data straight to the bad guys.
The second major risk is a new spin on a classic vulnerability from the world of computer science, the confused deputy problem. It's an attack where you trick a program that has a lot of power into misusing its authority for you.
And the attack is frighteningly simple. Step 1. An attacker gives the AI a totally innocent-sounding prompt.
Step 2. The AI, which is our confused party, doesn't understand the security context, so it just passes the command along to the very powerful MCP server. Step 3. The server, our deputy, checks its own permissions, which are super high, and executes the command, completely bypassing the original user's much more limited access. Bam! Data leaked.
And the result here is severe. This quote from the source material says it all. The attacker bypasses all the normal security controls. How? By exploiting that built-in trust between the AI and the server. It's a textbook privilege escalation attack, and the AI is basically an unwitting accomplice.
So what do we do? With all these scary new threats, is the whole idea just too dangerous? Not at all. The path forward isn't to get rid of MCP, but to tame it. Big companies are quickly realizing they can't just use the pure protocol. They have to wrap it, very carefully, in multiple layers of security and control. This means building what's basically a secure cage around the protocol. You enforce strict allow lists, so only approved tools can even connect. You use gateways to inspect all the traffic going back and forth. And for anything really high risk, you absolutely mandate a human in the loop. A real person has to click approve. It's all about adding smart defensive layers.
And this really is the key takeaway for all of this. MCP gives us the common language for AI to finally act in the world, which is a huge leap forward in capability. But the real work, the real responsibility for any organization using it is building the control framework around it to make sure it acts safely and predictably.
And that leaves us with a pretty massive question for the future, doesn't it? As these AI agents get smarter, more capable, and more autonomous, the single most important thing we're going to have to figure out is how we build the guardrails to make damn sure they're acting for us and not against us.